In this demo, we will show you how you can use Swift to perform the cross-cloud, cross-version migration of the containerized applications. For this demo, we have deployed WordPress application on the AWS EKS cluster, and we will replicate it to the IBM EKS cluster using Swift. Now let's look at both the environments and the application that we're going to replicate. This is the Amazon EKS cluster running KTS version 1.21, and it is located in the Frankfurt region. Now, since Amazon doesn't provide the dashboard, we have deployed a KTS dashboard onto this cluster. Let's access it now. So this is the namespace where we've deployed the WordPress application. We can see the workload objects here. We can see there is one deployment WordPress, which is the front end of the application. And there is one stateful set MariaDB, which is the backend of the application. Now let's look at the persistent volume claims. Here we can see that there are two PVCs that belong to the WordPress application, and both are using the standard GP2 storage, which is the storage class for elastic block storage. For replication, Swift will provide you an option to choose the storage for the replicated app on the target. And during the replication, Swift will sync all the KTS objects that belong to the WordPress application and also convert the storage into the selected IBM storage. Now let's access the web application. So this is the Blogger application that we are going to replicate today. And we have created a sample post here for the demo purpose. Now let's access the target environment. So target is the IBM EKS cluster running KTS version 1.22. And it is also created in the Frankfurt region. Now let's access its dashboard. We have created an empty namespace WordPress here and also created a secret inside it. This is the secret we created. This is needed to configure access to the registry where the try image is located. And try basically stands for transient RackWare agent image. It's a custom image which is deployed with the Swift product, and you can register it under the private registry. So, to configure access to that registry, you need this secret pre-created. And during the replication, Swift will create an instance of it on both source and the target cluster for the staging purpose. Currently, this is a manual step, but in the upcoming release, we've automated this step and Swift will automatically create the secret for you. Now let's look at the Swift server. It's a CentOS 7 based virtual server created on the IBM Cloud, and we've installed the Swift application onto this server. Apart from this, we haven't done any special settings or network configuration for this VM. So to access the Swift server, you need to copy this IP address and append the Swift dashboard to it, and you'll be landed onto the Swift login page. So during the Swift installation step, you need to configure the password for the admin user. And after logging into the Swift, you can add multiple users to the Swift. And if in case you need some guidance on the Swift operations, you can download the guide from here. For now, let's log into the Swift server. Since there are no clusters added to the Swift, we have landed into the cluster administration page. Let's add both the clusters one by one. So first we'll be adding the Amazon EKS cluster. Let's add the cluster now. Similarly, let's add the IBM EKS cluster. Let's add the IBM cluster. The cluster is being now added. And once the cluster is discovered, you can expand the cluster name and can see the rest of the details. During the steps, Swift will gather all the metadata of the clusters, like the namespaces it has and other KTS objects too. Both the clusters have now been added. Let's check one of the clusters. In the namespaces, we can see these namespaces which are present on the EKS cluster. Let's expand WordPress. Here you can see that there are two pods present inside this namespace. You can also list objects of another type by selecting the kind here. And we can see that two PVCs are listed in here. Now, since both the clusters are added, we can start the replication. So let's go to the sync administration page and click on the all replication. For migration use case, you need to select the pass-through mode. which will do the lift and shift replication. In this mode, Swift won't save any backup of your application, but will only migrate the application from your source cluster to the target cluster. Now let's select the source detail. So source is AWS EKS Cluster. Namespace is WordPress, where the application is deployed. The next option is whether you want to sync all the apps present inside your namespace or whether you want to sync a particular app from your namespace. So if in case your namespace has multiple applications and you want to select a particular application or particular object, you can do it by selecting here. And you also need to provide the object kind here. So if you select service, Swift will list the services present inside your namespace, and you need to select the service. And Swift, during the replication, Swift will identify all the objects that are related to the service and will sync all of them. For now, let's select add, since there is only one app present inside the namespace. Now, similarly, let's provide the target details. So target is IKS production in our case, and namespace is the WordPress, which is an empty namespace we created beforehand. Here, Swift will list all the storage classes that are present on the target, and you can use any one of them for the replicated app. Provide the zone name here. The next set of options is the try options. Here you need to select the type of service for the try. Since we don't have any direct connectivity between the clusters and the Swift server, we'll be selecting load balancer for both the services. And here you need to provide the ports for the try service. So if you have this port range whitelisted in your firewalls, then you can auto select these ports. Otherwise, you need to provide the ports here. So these ports will automatically be opened in your cloud firewalls. Let's provide the friendly name for the sync. In the advanced options, you can see that there are a lot of options available here. So you can execute pre-post scripts and also apply pre-post YAMLs. So this will be applied before and after the replication. Swift also allows you to customize your application. So here, if you want to change the type of your service to another, you need to select the service here and select the new type here. And if you want to change the port of your service, then you need to select the service, select the port that you want to change, and provide the new port here. Now, if you want to include or exclude a particular volume from the sync, then you can select that volume here and click on the add button to start the replication. So during the replication, Swift will do these conversions and the new replicated application will be using these inputs. Now let's start the sync. The PT sync has now started and we can see the live checkpoints here. So currently Swift is rediscovering both source and the target cluster to get the latest state of the clusters. Swift also allows you to pause the sync job and also resume it afterwards. You can also cancel it if you want. For now, let's wait for the PT sync job to finish. While the replication is going on, let's access the source app. So this is the source app. If we refresh it, we can see that the app is still live. And if we go to the dashboard, let's log in. Here we can see that the application's workload objects are still live and there was no effect of the replication on the source application. Now let's go back. The replication has finished. You can expand it to check the summary of the job. Then in the object sync statistics, you can see all the objects that the Swift synced to the target. In the data sync statistics, you can see how much data was transferred. You can see that there are 2 PVCs that were synced as a part of this replication. In the sync progress, you will be able to see all the checkpoints of the replication. Now let's check the target app. So let's go to the dashboard of the target cluster. Let's access the WordPress service. And here we can see that the replication was successful.